What is the distance between the origin and the line 3x minus 4y equals negative 10? I had written 3x plus 4y, but it's actually minus 3y for this example. So there's actually a formula for finding the distance between a point and a line. The origin is just a point, right? We could say it's 0.00. And this line is written in standard form, right? Anytime you have a line in standard form, you'll see ax plus by. It can either be plus c equals 0 or equals c. Either way, it's standard form. Probably a little more commonly you'll see ax plus by plus c equals 0. And we can write it in y equals mx plus b format if we want to get an idea of how to graph it. So we could subtract 3x from both sides and we'll get negative 4y equals negative 3x minus 10, and then divide by negative 4, so y equals 3/4 x. Actually, I believe this is supposed to be plus 10. So then this becomes, just take my, it doesn't matter, but just take my word for the sake of the example. 10 over negative 4 is minus 5/2, or 2.5. So certainly you could do this regardless of what the signs are. Anyway, that's y equals mx plus b. That's a line we know how to graph. So we can do y-intercept of negative 2.5. That's about right here, and it has a slope of positive 3/4. So that's our line. I'm sure it extends beyond that as well. But the question is, what's the distance between the origin and that line? Well, we could draw a line from the origin to any point on that line, right? And those distances would all be different. But it's implied in the question that they want to know the shortest distance. They want to know the shortest path between this point and this line. So it's going to be the altitude. It's going to be the line that meets at a right angle. And the formula for finding that distance is the absolute value of the equation of the line written in standard form where everything is set equal to 0. So you want this version, not this version. So in our case, well, let's write it generally first and then we'll write it for our case. So that's ax1, and there's a reason why I'm putting x1, because we're actually going to use the point in the equation. b y1, and then plus c, and close absolute value. And that's all divided by the square root of x squared plus, no, that's not right, a squared plus b squared. And this formula will give you the shortest path distance between the point and the line. The line that is described by ax plus by plus c, which in our case is this guy, except we just have to subtract the 10 over. So let's actually just do that right now. This is all yx plus b format, but let's write it in standard form that matches this. We would get 3x minus 4y, and then we just have to subtract the 10 over. Minus 10 equals 0. And then x1 and y1 are the coordinates of the point that we want to know the distance away for. So in this case, x1 is 0 and y1 is 0 because we want to know the distance from the origin. So now we can actually plug it in. Our distance, so this is distance, the distance we want is the absolute value of 3 times 0 minus 4 times 0 plus c, where c is negative 10, so minus 10 absolute value. And that's all being divided by the square root of a squared plus b squared, where a is 3, so 3 squared, plus b is 4, well it's negative 4, but it doesn't matter because we're squaring it, squared. And since these are 0, these don't do anything, so it's just negative 10 absolute value. Absolute value of negative 10 is 10. And 3 squared plus 4 squared is 16, and 9, which is 25. Square root of 25 is 5. 10 over 5 is 2. So the distance between this line, whose equation is this, or this if you like, however you prefer to write it, and the origin, the point 0, 0, is 2, and it's determined by this formula here. So the formula is basically the absolute value of the equation in standard form, where the point x1, y1 has been substituted in for those coordinates, and the coefficients a and b have been squared, added together, and square rooted in the denominator. And you have to take the absolute value of the numerator, otherwise you'll get negative 2, which makes no sense because you can't have a negative distance.